Calculus Homework Help. For any homework-related queries, call us at +1 678 648 4277. You can mail us at support@mathhomeworksolver.com or reach us at https://www.mathhomeworksolver.com. mathhomeworksolver.com. Single variable calculus problem. Problem 1. This problem sketches a systematic method for finding antiderivatives of expressions f, sin, theta, cos is theta, where f is a fraction of polynomials. A. With the substitution tan theta/2 equals z, verify that. Please try this on your own first. However, if you are very stuck, take a look at problem 5e12 in the course reader. B. By example 3 on p. 571 of the textbook, the polar equation of the conic section with eccentricity e and focal parameter p e is. Set up the integral for the area of the region bounded by 0 less than or equal to r less than or equal to f, theta, for a less than or equal to theta less than or equal to a. Use a to turn this into an integral involving only z equals tan theta/2. Use the non-negative constant. mathhomeworksolver.com. To simplify your answer. Answer. You need not evaluate the integral. Problem 2. A. Read through section 10.3. It is only 3.5 pages. Everybody will get credit for this part. B. Use problem 1. A. To rewrite the integral as an integral involving only z equals tan theta/2. C. Assume n greater than or equal to 2. Use the following integration by parts to find a reduction formula of the form. Not to be turned in. Of these three methods for evaluating the integral, which would be easiest to use and fastest on an exam? mathhomeworksolver.com. Solution to A. Since tan alpha equals x and tan beta equals a plus b, we obtain. Solution. Solution to SE. The term a 2 minus x2 suggests the substituent x equals a sin theta, and this leads to integration of sec theta at the end. While this is okay, as long as you know that sec theta d theta equals ln sec theta plus tan theta plus c, there are easier ways. We can use either partial fractions or inverse substitution. X equals a tan t. A method of partial fractions proceeds as follows. mathhomeworksolver.com. The Heaviside method, or multiplying out and letting x equals a, x equals and 1 to a equals b, straightforward integration, we obtain minus a yields, respectively, 1 to a equals a. Solution to D. The radical, a 2 minus x2, minus 3/2 suggests the substituent x equals a sin theta, dx equals a cos theta d theta, which leads to. Solution to E. We first need to work on the radical square root x2 plus 2x minus 3. In an attempt to complete the expression under the square root to a perfect square, we notice that x2 plus 2x minus 3 equals x2 plus 2x plus 1 minus 4 equals x plus 1, 2 minus 4. This inspires the substituent u equals x plus 1, do equals dx. Then our integral becomes which, because of the radical square root u2 minus 22 is screaming for the change of variables u equals 2 seconds theta, do equals 2 seconds theta tan theta d theta. Then our integral equals mathhomeworksolver.com. Solution to f. As the nominator is a second-order polynomial and the denominator is a third-order one, we can directly proceed into decomposing this rational expression into its partial fractions. First, we factor the denominator x3 plus 2x plus x. The factor x is obvious. x3 plus 2x plus x equals x2 plus 2x plus 1, and the remaining part is just x plus 1, 2. Therefore, we can write. The Heaviside cover-up method goes as follows. Covering terms without 1/x and assigning x equals 0, we obtain minus 4x2 minus 5x minus 3 equals 11 0 plus 0 minus 3 equals a, I.ea equals minus 3. Similarly, covering terms without 1/x plus 1, 2 and x plus 1, 2 assigning x equals -1 yields -4 plus 5 -3, -1, equals 2 equals c. The other constant b cannot be determined from Heaviside method. Remember, Heaviside method does not give all the coefficients when there is a repeated factor, like here we have x plus 1, 2. So how do we find b? I am glad you asked. The easiest way is to plug in some arbitrary value for x. To keep the algebra simple, we put x equals 1 in. This yields b equals -1. Therefore, solution to VG, we decompose the given rational integrand into partial fractions as mathhomeworksolver.com. Multiplying out yields for times 2 plus 2x plus 4 is equal to a times 2 plus 4a plus bx plus cx2, equating the coefficients of x2, x and 1 respectively, we obtain a equals 4 plus c, 2 equals b, and 4 equals 4a, hence a equals 1. Therefore c equals 3 from the first equation. Using the fact that to integrate the second term and making the easy substitution u equals x2 plus 4 to integrate the last term, we obtain solution to h, let u equals sin ln x, dv equals dx, then do equals x cos ln x, and v equals x. The integration by parts formula then yields. We need only one more integration by parts, this time with u equals cos ln x, do equals x minus sin ln x, dv equals dx, v equals x, to obtain mathhomeworksolver.com. Rearranging this and dividing by 2, we obtain solution to I. We write and implement integrand by parts with u equals cos n minus 1, x, dv equals cos, x, dx, and do equals n minus 1, cos n minus 2, x, sin x, dx, v equals sin x. Therefore, rearranging this equation, we obtain the sought recursion formula solution to j. Using our result to I, we can write mathhomeworksolver.com. Observe that cos n minus 1, x, sin x, pi slash 2 is 0 for n greater than or equal to 2. Let us call. Combined with this observation, the recursion formula of I gives. Here the values have been found directly for n equals 0 and n equals 1. Therefore, Part 2 Problem 1. This problem sketches a systematic method for finding antiderivatives of expressions f, sin, theta, cos is theta, where f is a fraction of polynomials. A. With the substitution tan, theta slash 2 equals z, verify that. Please try this on your own first. However, if you are very stuck, take a look at problem 5e12 in the course reader. mathhomeworksolver.com. Solution to A. Using the double angle formula for tangents, we have tan theta equals 2 tan theta, 2 we then 1 minus tan 2 theta, 2 draw the right triangle with two right sides having length 2z and 1 minus z2 yields the hypotenuse, h2 equals 1 minus z2, 2 plus 2z, 2 equals 1 plus 2z2 plus z4 equals 1 plus z2, 2. Therefore the hypotenuse. Pythagorean theorem has length h equals 1 plus z2. Now, we can easily read off the values. B. By example 3 on p. 571 of the textbook, the polar equation of the conic section with eccentricity e and focal parameter p e is. Set up the integral for the area of the region bounded by 0 less than or equal to r less than or equal to f, theta. For a less than or equal to theta less than or equal to a, use a, to turn this into an integral involving only z equals tan, theta slash 2. Use the non-negative constant. To simplify your answer, you need not evaluate the integral. Solution to B. Remembering the area formula for curves in polar coordinates, the required area is mathhomeworksolver.com. We now plug in the substitution given by 7 and obtain. Using the suggested notation plus or minus b2 equals 1 minus